Hello everyone. In this video, we are going to discuss about link state routing algorithm. The link state routing algorithm working under the OSPF routing protocol, open shortest path first. Before entering into the link state algorithm, the previous video we discussed about the distance vector routing algorithm for the RIP, so routing information protocols. So we know very well the RIP is a interior gateway protocol. So OSPF is also interior gateway protocol. So before entering to that link state algorithm and discussion of the OSPFs, so why we are just moving for that? So the RIP protocol, what are all the performance of the RIP protocol? That is, what is the advantages and then disadvantages of the RIP protocol? We can just given the overview so that we can easily understand about the working principles of the link state algorithm as well as the OSPF. So generally we are just checking the performance. So each and every algorithm have its own advantages as well as the disadvantages. So here the advantages of the RIP protocol, the first thing is a very easy configuration. So the configuration is a very easy, as well as it doesn't have any specific parameters like on other protocols. Then it's a message formats are very simple, and it can send only the neighbor routers, that is those who are having the local, so it will be sending their messages. So it is using the distance vector algorithm, so we know very well. The convergence of the forwarding tables is also very simple. But what is the problem here in this RIP protocol, in the sense that is your disadvantage of our RIP protocol? Maximum it will allow only the 15 hap cards. So that is the biggest disadvantages of the RIP protocol. So when the domain is going to be the larger, so at the time the RIP protocol will not work perfectly. So that the most of the environment, the networking environment nowadays, they are not preferring the RIP protocol. Similarly, so due to this, the scalability. So scalability we know very well. So whenever we need to extend or otherwise minimize the automatical adoption, it must be there, right? So that the scalability is, it's called as a very poor in our RIP protocol. Okay, as well as the robustness, the distance vector concept. Each router it's sending its what it notes about the whole domain to its neighbor. So the calculation of forwarding table on the information receiving from the immediate neighbors. If there is any failure or corruption in one router means the problem will occur in the all the routers and forwarding the each will be affected. So these are all the problems we are just facing under the RIP protocol, so that we are just moving for the open shortest path first algorithm. Under the open shortest path first algorithm, mainly it is based on working with the link state algorithm. So that link state algorithm it's also called as the simply LS. So what is the main principles of the link state algorithm? It is also follows as well as creating the least cost tree. Similarly, our distance vector and forwarding the table. So this method is using the link state. It is defining the characteristics of our link. So the link with the lower cost or link with the higher cost. If the link is infinite means it may be the link does not exist, or otherwise it may be the broken. Okay, so we are just creating the first link state database. So what is a linked state database in the sense? To creating a least cost tree, each node to complete the map of the network. That means it needs to know the state of the each and every link. So all the collections of the states for the links is called as a linked state database. Okay, so the linked state database, it is containing the collection of states for all the links. Okay, so that information will be available under our link state database, that is called as the LSDB. So the LSDB is the most important thing. So only one LSDB for the whole network. So each node have its any uh, duplicate cells or whatever it is, that it will be updated here. Okay, so it's like as a 2D array, so like as our matrix format. So the rows and columns will be available, so each and every node, so which value of each cell is defining the cost, so the corresponding to the link, it is going to be mentioned here. So this is our link state database introduction. So now we will just look on with one example how the link state database are going to be created. So the diagram, the topologies will be like this. The same diagram I've just taken, which one we solved for the RIP protocol. Here G, and then with the values. So A to B, the 2, here 5, and 3, 4, 1, 4, 2, 5, and here 3. So how to each node can create this link state database means it contains the information about the whole network, right? So it is done by the flooding. So what is meant by flooding means each node can send some greeting information to the all its neighbor. For example, the A have some information means, so it is sending some greeting information to this immediate neighbor. So immediate neighbor for the A is only the B and D. So which nodes are directly connected to with that node, so that is called as the immediate neighbors. So that is sending some greeting messages to the all the directly connected. So what kind of the information it will be sending means it contains the two piece information. So what is the two piece information means? The first one is the identity of the node. First one is identity of the node and second one is the cost of link. So this is the two piece information. It's called as a LS package. Okay, so LSP. It's called as the LSP. So the formation of the least cost trees. So how it will be forming in the sense. So here they are just applying the Dijistra's algorithm. So based on the Dijistra's algorithm, in this protocol, they are just forming the least cost tree. So we know very well that Dijistra's algorithm is working for the smallest, shortest path graph, right? So based on that, they are just creating the least cost tree for the each and every network. So now for this network, so what is the initial the database is going to be here. I'll just make it here with the table. What are the nodes? So A, B, C, D, E, F, and G. And then similarly A, B, so 2D array, right? So D, E, F, and G. So we're just going to be make the 2D matrix. Each and every columns and rows. or C, D, E, F. So now what is the distance between A and A? So it is obviously 0. A to B, it is 2. A to C. So A to C, it's not directly connected. So A doesn't aware about the C. So it is infinite. So that is going to be mentioned as a infinite. And A to D distance is 3 and E, F, G. So all the things are unaware initially. So it is going to be marked as infinite. Okay. So in this graph, each and every node, what are all the neighbors, immediate neighbors, the distance alone we can fill it now. Remaining it's a unaware, so we can able to mark it as a infinite. So based on that, we can fill the all the things. So here A to B is 2, and then B to B is 0 and 5 and infinite, 4, infinite, infinite. So similarly for the C, infinite, and C to B, it's a 5, and C to C 0, C to D, the distance is infinite, infinite, 4 and 3. So for the D, if we are just filling 3, infinite, infinite, and then 0, 5, infinite, infinite. So E 0, 4, sorry, not 0, infinite. A to E is infinite, 4 as well as infinite, 5 and 0, 2 and infinite. And A to F again infinite, this is 2, and C 4, infinite, 2, 0, 1. And here infinite, infinite, this is 1 is 3, and infinite, infinite, and 1 and 0. So this is the initial the database information. So later, one by one, the based on the Dijistra's algorithm, it will be finding the least cost tree. Based on this, then we can form the uh, working with the OSPF protocol. Okay, so now we can form the uh, Eastcast tree for this example. So initially all the nodes are available, so they are not creating any links for this. With that data we can format, so F and G. So what is the distance between A to B? A to B, the distance is 2, and A to D, the distance is 3. So now we are just taken this is as our root. Okay, so now we can one by one the iterations are going to be happen. So the A to B, the link is going to be created, so which one is the minimum as well as the direct. So remaining everything is a infinite because it is a link is doesn't aware about these nodes. So either we need to make this it's enable or not, so we have to check until the next iteration only this will be enabled. So now the link is made with the A and B. So from the B we can able to access C and E. So this is the accessible one, but we need to decide whether it is possible or not. In the next iteration, the second iteration, so there is no other way for to reaching the D. So the A is going to be now making the link for A to D. So this is the second iteration. So now from the D you can able to access others, right? So like that one by one it is going to be happen. So then the third iteration we are checking the distance between here to and here. So what is the distance? So if you are just reaching the C, it's a totally 7 it will come, and as well as reaching the E it will become as a 6. So now we are just active this link. This is the third iteration, so this link is going to be enabled. Now the E is the known one, so from the E we can able to access the F. So if it is making the access, the 8 is the distance. Okay, so the next iteration we can enable the C. So it is the minimum comparatively. The fourth iteration, we are just making the link for the C. Okay, so now from the C you can able to access the G. Okay, so the next iteration, the fifth one, we are just enabling the F. From the F you can access the G. Okay, from the F also you can access, from the C also you can able to access. So which one is the minimum, you can able to find it. So now this is the minimum one. From the F we are just making the link, so this link is going to be disabled. So now the value will become as a none. So this is the least cost tree based on the Dijistra's algorithm. Now we are just creating. So now what is the RIP protocol and then what is OSPF protocol? So what is the main difference between these two things? So both are finding or as well as working with the least cost tree. So what is the main difference between these two algorithms? So that we need to find it. So RIP protocols following the distance vector and then OSPF following the link state. Both are working with the least cost tree only, but what it is a difference? Okay, so the main difference between this, sharing the information. Okay, distance vector algorithm, how it is working means each router. Okay, so the each router, it is going to tell its neighbors, okay, what it knows, what it knows about the whole network. That is a thing. Each and every router, for example, the A is now it's going to be tell its neighbors, so B and D, okay, what it knows about the whole network. So what I just know about the whole network, I'm just going to be tell about the my neighbors. But what is the link state algorithm which will be do in the sense each router tells the whole network what it knows about their neighbors. That is the difference. Okay, simply if we want to tell about, if we are just speaking the gossips, right? So distance vector, how the gossip it will be spent means, if any one information you know about entire the section, your section. Okay, for example, you are studying under the A section means, so some gossips you know about A section means, so that gossip you're going to be tell to it's your own close friends. That is the job it's doing distance vector. Link statements, so you know some gossips about your whole friends. Okay, so that information you are just spreading to the entire the class. That is the thing it's doing link state. Each router tells the to the whole network what know it's about snake. Okay, so this is the difference between the distance vector as well as the link state algorithm. So I'll just give in a diagrammatic representation also for your easy understanding how it's working. For example, this is the A, B and D, right? So this is neighbors, right? So now this is your whole network. Now each router to tell about its neighbors about the whole network. So the whole information gossip is going to be reach your friends. Okay, but the link state, this is the A, B, D. Now we are just going to be tell the information to the whole the networks, your friends gossips. The A and B, what it knows, they are just going to be shared with your whole network. Okay, that is the difference between the distance vector and then link state algorithm. Now the OSPF also the intra-domain routing protocol only. It's like as a RIP protocol, but here we are just overcoming the demerits of the RIP protocol, and there is no cast, that is a matrix wise there is no cast is here. And here the OSPF we can able to work with the single area as well as a multi area things, huge autonomous system we can able to work on it. So the next session we will discuss about our open shortest path dynamic routing algorithm. Thank you.